Okay, so first, yeah, I mean, thanks for the invitation. Yeah, it's an honor for the VGV team always participate with the community. And today, yeah, we were thinking about, okay, how can we contribute to that event? So we were thinking on different ideas, and one of the, I think I consider like really, really important is really how to start a project. I think it's one of the questions that I receive more as an organizer or as a speaker. Like, okay, how you start a project, or how you organize your folders, how you do like many, let's say, all this stuff that you don't really, I mean, it's just you do it once at the beginning, but you waste a lot of time. So yeah, we thought like, okay, let's use the tool that we already have, the very good CLI, and how can we provide that, or how can you take advantage of that. So yeah, we have the recipe for making a very good app. So first, who I am. So yeah, I recently joined VGV team. I've been working on different technologies, not just Flutter, but I've been working with Android like for a year or two. Also, I've been in business intelligence, in security, and also one of the recent ones, it was Xamarin. That is another framework I was working for like almost 3 years. But I discovered in 2019 Flutter, and since there I'm really working full time with that. I'm also participating a lot in the community, especially with the Spanish community, as an organizer of the Flutter Spanish team there. I'm also participating with the Flutter Madrid team. And yeah, you can find me on my social media, especially on Twitter, is where I'm most active. But basically in Spanish, most of the time. Some others in English, but most of the time in Spanish. What about you, Jay?
There we go. Hi everyone. I'm Jay, actually Jeroen, but yeah, try to pronounce that if you're not Dutch. Yeah, I'm a also an engineer over at Very Good Ventures as a freelancer. I also I'm currently doing a degree in computer science, which I'm almost done with, so that's cool. Other than that, I also participate in some aspects of the community. I'm a Flutter and Dart GDE, and I keep myself busy with managing stuff like the Flutter community organization, the GitHub and Medium, and the Slack group that we have for that, providing support, that kind of thing. Most of the time, I'm working with Flutter or tooling around Flutter and a little bit of TypeScript where I can do so. Yeah, and I'm on GitHub. I have a couple projects there. I'm on Twitter as well if you want to hit me up or ask any questions or something like that. And I'm very excited about the tool that we're showing today because it takes off a lot of the bootstrapping work that everybody has to deal with. And I'm doing so with a wonderful team. So excited to get started.
Cool, cool, cool. So yeah, a little bit for the ones that don't know about Very Good Ventures. So basically, we are an agency fully focused on Flutter development. We have teams like here in Europe, for example, with Jay and I. Felix, it's in America, in United States. I mean, we have more people there, basically in some other places around. So what we are doing is, as I said, we are totally focused on the Flutter development, and we help the people, and we help the not just startups, we help other teams to use Flutter as well. And as we already mentioned, most of the people in Very Good Ventures, we are really participating in the Flutter community. Like, it's one of the things we like the most. You can take a look also to our GitHub. You will see that there are even some of this stuff that we are talking today. It's also in our repo there. You can take a look also to our social media. We post some advantages of Flutter, things like that you can take a look. And of course, one of the things that we are proud the most is about all the clients or all the people that we participate with. One of the most important, I think it was Hamilton, because it was one of the first application that was released with Flutter. So we are really proud of it. But also, yeah, New York Times, we are collaborating with Google as well as many as other. Yeah, if you can take a look, you will see that in the website. So I will not borrow you many time for that. And so yeah, what we are talking today, basically, as we said, how to start an application. So we are gonna present what is very good CLI. So how to start and what are the things that is gonna bring you to your project. And yeah, first we will do like a first introduction of it, and also the demo app that we will present. And of course, if you have any questions, we will reply that at the end. Okay, so what is very good CLI? So the first thing that you will find it is like it's free, so you can check. It's like a normal package that you can find on the PubDev. So don't hesitate to take a look there. Basically, as I said before, it's really a very good way to start any project. This is something that is really working for us for VGV as a team. It might not work for everyone. I mean, it might not be in all the cases, but at least in the situations that we use it, it works. But this very good CLI is specifically thought for individual Flutter developers, so people like you, that you are starting a project and you don't want to waste much time at the beginning with that. So this is really highly recommended for these cases. So how we use it, I mean, it's really simple. It's just 2 steps. So you will activate with, I mean, if you already have installed that, I assume that is that yes, if you have already Dart, basically you just need to activate the very good CLI with the pub global activate. And after that, you can just run the very good create command, and that's it. Yeah, in less, as you can see, in 0.03 milliseconds, you have your application ready. So it basically is working like every other command in Flutter, like the Flutter create, but it's taking the advantage of our template for it. So what we get, we will go in details later, but yeah, basically cross-platform support, flavors, internationalization support, null safety, BLoC, testing, logging, very good analysis, and continuous integration. So as I said, yeah, we will go in details. The cross-platform, yeah, that it's built on. So first, the iOS and Android. Yeah, as you might know, we have Flutter that is not just for iOS and Android applications. We have also the web applications that is stable since, I don't know, couple of almost 2 months. And desktop is coming soon. Flavors for the ones that never work on that, or they might have an idea of what it is. So basically, when you are building an application, you might have different environments. So different environments because, for example, if you are testing your application, you might want to be in a test environment for that. Or if you want to really test in what it is the production application, you might want that. So this is something that is a bit tricky to handle, but more or less every production application is gonna need. So we give that directly. So you have the development, the staging, and the production, and the 3 of them are ready to use. Internationalization. So as well, if you produce like a normal application, at some point you need to add different language to it. So it's a bit complicated to, I mean, if you don't know at the beginning Flutter, because it's using the synthetic code generation, that sometimes for beginners is not so easy to go through. So with that, you don't need to worry about that. You just need to take care of the existing language that we provide. And if you want to provide another, you just need to copy paste one of the files and add a new language support if you want to. Null safety, for the ones that don't know, since the last event, the Flutter Engage, now we have the version of Flutter 2.0. It brings a lot of news, but one of the biggest news, it was the null safety. This is one of the things that the Flutter team has been, I mean, the Dart team has been working more on it, like for 1 year, and we support it, of course, since the version, as I said, the 2.0. And of course, yeah, as you might notice, so we have Felix is one of our team members. So we are using BLoC, but we are not just using BLoC because of Felix is our team. We really think that is one stage management that provide the architecture good enough for scalable projects. When we mean scalable, we mean that if we want to bring another feature to our application, we can integrate it easily. And this is something that it goes with the test. So it's really important for us, the test as well. And with the BLoC library, it's really easy to test all the different states that you can have in the application. And of course, because we think that is a clear way to have the business logic separation and the presentation. So the presentation, the part that is the UI. You can take a look, of course, as you can see in the GitHub of Felix. It's open source as well. And as I mentioned, testing is really important for us. So of course, we provide in this very good CLI really a good way for the testing, like the starting point at least. So as you might know or not, we have 3 different kind of testing. One is the unit testing. So you might think on unit testing, for example, if you are testing a calculator and you want to sum up 2 numbers. So if you want to try this, you might need to use the unit testing. So that's what we call it. We have also the widget testing. So basically, it's how behave or how it is in the screen widget. So for example, if you want to try the behavior when you click in a button, so you can find the button with the widget testing and you can use it as well. And of course, all the projects and all the demo that you will see today is with 100 line coverage testing. So basically is the way that you cannot have function because right now, I mean, we just have the line coverage. So it doesn't mean that your application is not gonna fail in all the scenarios, but at least you are 100% sure that it's gonna be cover all the lines in your test file. And of course, we will be with the integration test coming soon. We don't know why, but we don't know when. Sorry, but we will have it. And very good analysis. It's also really important for us because as a team, we might want to have like some kind of rules, let's say, in terms of coding. Like, for example, if we want to avoid to don't have const widget, things like that, or that might be useful. For example, when you jump from one project to other, we have that in the very good analysis. You can take a look also, even if you don't use the very good CLI, you can install it as a package. It's also open source. You can find it as well in the pubdev, and you can put some on the, you can have more strong mode or not, but yeah, basically is what we are using in our day-to-day in very good Ventures. Continuous integration, for the ones that don't know, is basically how your application, for example, if you have your app in GitHub, so basically when you have your branch, you finish your development, you push your changes, and you want that these changes going to the main application. So we have also that include in that with the GitHub Actions, we have different set of rules. In that case, for example, the format, the analyzer, and also, of course, the testing, that are really important for us to go through all the steps. So basically, if any of these tests, any of this part fail, your application will not be, your branch will not be merged, for example. And of course, the test coverage, as we said before, we tend to be 100% line coverage. So you can have also the GitHub action for the coverage that is also out of the box for that. You can use it separately if you want. And as you might all be like really see how it's working, we might go on, like, Jay, you can start sharing your screen.
Sure.
And show them.
Let's get started. There we go. So yeah, thanks for that, Óscar. In no small part has Felix bears mentioning that Felix has brought the whole very good CLI project, brought that up from the very start. So huge kudos to him for spearheading that that project. It's really a group effort, but yeah. It's a lot of fun to work on as well. So and he just put the link to the demo app in the chat here, so that's perfect. If you want to check this out, you can check it out right away yourself. I'd love to hear from the people if the chat, or rather the font size, needs to be increased or anything like that. But as far as this goes, hi and welcome to like a small demo of like an application built with very good start. What we're going to be looking at today is an application that uses a real API that pulls in data from the space, from like this unofficial SpaceX API, and displays it on the screen with some routing. We're using BLoC, or in this case, qubits, actually. If you're not familiar with that, there's some great documentation around how to use qubits and BLoC, so you can look out for that. But I'll demo a little bit of that here as well. So we're just going to be going through this application and see what parts it consists of and how it's built. And again, everything of this is open source, including all the commits. It's 100% tested and full code coverage on everything, including the packages. So take a look yourself if you want to, but I'm just going to guide you through how this example application is built, sort of as an inspiration of how you might build an app like this yourself. And this can very easily scale into like a bigger application and be an actual useful application for any type of user. So let's have a look here. So if we look on the left-hand side, this should look very familiar to you if you've ever used Flutter before or built a project yourself. Let's have a look at lib first. So lib here, the interesting bit here are, ignore the fact that this is blue, made a small edit probably, but other than that, it's all good. Usually how lib is structured depends on what type of project you're building, right? It also depends on what architecture you're using, how you're structuring your files in general. So in this case, I'm going to go over the structure that we have right here. So first off, app. This is going to be the root widget of the project. And so the project, when it starts, will first go into this app class here. It mainly consists of a repository provider that will provide any repositories, so these like data layers for your applications, for this app, I mean, and then the view itself, which is just a material app with some theme data on it. So we have some nice colors here, some dark mode, that kind of thing. Then the localizations, this is all done for you automatically as well. The localizations are injected, and then we render our homepage in this case. So that's the app folder. Next up, I'm going to talk about localization. So the L10N here stands for localization. It contains one file itself, which is this, which is just an extension to help you easily get the current localization of the project, which means that you can quite easily get the strings that you need to display on the screen here. So inside the localization, we have some ARB files. Now, these are the files that you can give to a translator that they can translate themselves into any other language, for example, Spanish, as we have here, though it's not up to date, but it could be. This is where all our strings are that need to be that we need to be able to translate later on. In this case, it doesn't have that much, just like a first launch thing, an app bar demo, like an error state, that kind of thing. So not really that, exciting, but it's still nice to have out of the box. Then what we also have in the root of lib is the 3 main files. So currently, these all just have a main function and start the application. So in this case, we have production, as Óscar said, we have production, staging, and development. Now in this case, all of these do the same thing, right? They set up the same repository, they run the app in the same way. But if you have different APIs, what you could do is, for example, for your production, have one configuration of your API that makes sure that you go to a production server or have some key switched out. And then for staging and development, have separate keys or separate server endpoints so that you can easily test these. Another thing is that you can do it so you could have like production run on a production server, development on a development server, and then you could have staging just use like mock data, for example. And your UI would be none the wiser, right? That's the great thing, is that your UI will just work regardless of how you run the project. So those are the main files. And then getting into a bit more of the UI. Before I do so, I want to take a quick look at our pub spec. Because this contains all our dependencies, metadata about our application, and so that's what we have here. Now, ignore this link; this is outdated, and I was sure that I was on the last version of this branch, but I might not be. That's totally fine. So here we have the name, description, version, obviously all the default stuff what we have here. We do support null safety, which means that we run from Dart SDK 2.12 and up. So that means that you need to have Flutter 2.0 or up. Any version after that is completely fine. I'm running on the latest Flutter version, in this case, 2.05. Then for our dependencies, we set it up like this. So we have regular dependencies, BLoC, Flutter BLoC, Intel, which is internationalization to make that support easier. We have a URL launcher because we're going to launch a URL in a little bit. And we have our local packages here that I'll get to in a minute. As far as development dependencies, most of this is just purely testing. We have our analysis here. Then all of these are related to testing. We have one for blocks, one for mocking images. We have some platform interface mocking, and a mock navigator, which is a package that is currently still in alpha, but it works, so that's good. So who knows what happens with that. And then the default Flutter stuff that makes sure that we generate all our synthetic code. Now, if we have a look here, I added another folder here, which is packages. And inside this packages folder, we'll have separate modules that each will be responsible for one thing or one domain. So this packages folder isn't in a very good start by default, because we give you the option to add it yourself if you want to, because making sort of this part of the architecture is really easy to do yourself. So that's not really an issue. But I added it here because that's how we usually do things ourselves. And we modularize everything that has to do with an API or a repository or some kind of storage, put that in a packages folder, make them separate packages. That way it's way easier to test and manage in the long run. So in here, I have two things. One is a SpaceX API, which will just reach out to the regular SpaceX API. Everything is documented and fully tested, obviously. And so here we just have one easy method call, which is fetch all rockets, which will be able to fetch all the rockets that we have, as you can see over here. Now that's the API. We have another package. So our front end will not directly communicate with the API itself. Instead, a repository will sit between our UI and our API. So the repository is responsible for taking a request from the front end and providing data that comes from the back end. In short, you can make a repository do a lot of things, but that's the main thing it does. And so in this case, all it does is take in an API client, usually the default one. But again, because we want to test it, we allow you to specify one yourself, which is a very common pattern as well. And in this case, it doesn't do much more than just fetch the rockets directly from the API and throw an exception otherwise. But you can obviously expand this to have a whole bunch of method calls. You can do local storage for caching, that kind of thing. So you can go all kinds of directions with this sort of setup. All of these have examples as well that you can run easily to make sure that everything works. And obviously, everything is 100% code coverage tested. So this contains all the tests for this package. And it's quite small because the package doesn't do a lot. SpaceX API is a little bit bigger, I believe. Here we check for the right exceptions. We check the happy paths that make sure that our code works properly when things go right. But when things go wrong, we want to make sure that we do the right thing, throw the right exceptions as well. SpaceX API also contains our models. So we just have one model, which is Rocket, which contains some information about, well, here it is. We have an ID, name, description, height, diameter, all this good stuff that we can use in the front end. But you can obviously expand this to be more to contain more fields that the actual API provides you. So those are the packages that are used by our application. Now for the UI bits. So how we structure this is, as Óscar has mentioned before, is we use BLoC in combination with provider. And for that, we use the Flutter BLoC package, which has BLoC providers and repository providers. So in this case, at the top of our application, we're injecting a sort of like dependency injection. We're injecting a Rocket repository. That way, any block or qubit further down the chain in the widget tree can use this Rocket repository to get all of its data, do requests, that kind of thing. So that's what we do at the top, so that we basically always have access to this repository. Then we build our app, and the third thing that we do is we build our homepage. So let's get into home here. Now, home contains a couple of folders and files. The only file that it contains itself is home.dart, and this is just an export file. Nice thing about this is if you have an export file like this in every folder, all you need to do to import everything in that folder is import the single file, because the rest is exported for you. It's very similar to how in JavaScript you can have an index.js file, which exports everything that's inside it. Makes it really easy to import everything and make sure that you have one import per feature, and also that you don't have like a whole list of super long imports for like very specific files. So a very common pattern that we also use in basically any folder that we have here. So home contains two things. First off, let me talk about the qubit. So there is a lot more documentation on qubits and BLoC and tutorials and examples and talks even by Felix himself as well. So you can look those up. But in very short, if I can explain it correctly without Felix being like, a qubit is basically this small class that has a certain state and gets events in. And when an event happens, you can emit new states. It's very akin to like a stream, so as a stream builder, but it has some convenience built in to make it more suitable for a state management pattern like this. And so, yeah, that's the whole thing in short. So the only thing that the qubit is supposed to do is have some state and manage it for us. And then the UI can listen to changes on that state and rebuild itself. That's how it happens. So the UI is only a function of a certain state and produces UI and sends new events to our qubit, and that's how the circle goes around. There's another talk I've done on unidirectional data flow that goes into more detail on how this all works. I can share a link on that if you're interested later on. So our home qubit needs a Rocket repository in order to do those requests. So that's what we take in here. We're using null safe Dart, which means that we don't need the @required syntax, but we just use the required keyword now. That makes sure that our Rocket repository is never nullable, which we want, which is perfect. And then our default state is just the default constructor of a home state, which I'll get to in a little bit. Home state contains two parts. One is a status, which is defined at the top of the home state. Let me go there. And that just tells us if we're in the initial state, so we haven't done anything yet, and we just started the app, so to speak. We have a loading state, which means that we're currently loading on the rockets. Success means that we do have a list of rockets. And failure means that some failure has occurred. We're not sure if we have a list of rockets, but we should display an error. That's the entire state, right? And then we have a list of the actual rockets that we might want to display here. So going into the qubit, we have one simple method, which is fetch all rockets. First, it emits a new home state that says, hey, we're loading. And if we had rockets, might as well, give them. Then we try to load the rockets from the repository that we got, and then we emit a success state if this all goes well, and we give it the rockets that we just received. If we get any exception whatsoever, we just emit a failure state to let our UI know that, hey, something has gone wrong. Please show some form of exception text or something, or like a reload button. You can do whatever you want. So that's our entire qubit, and so that's our entire state management as well. Because of the way that we use blocks and qubits, not just in Very Good Start, but the common pattern in general, we basically never need to have a stateful widget because all the state is managed in the qubits and the UI just listens to that state and rebuilds whenever some change happens. So if that's all clear by now, I'm sure some of you will have questions. We'll get into those at the Q&A. But let's just have a quick look at the view of the homepage and the rocket details, and then we're all good. So our homepage looks like this. First off, we need to construct one of these qubits, right? And then need to provide it to the rest of your UI. So just in the same way that we provided a single repository at the top of the app so that any BLoC can access it, in the same way we can provide a BLoC, or in this case, qubit, because qubits and blocks are very similar, and you can provide qubits instead of blocks. We can construct one of these home qubits and pick up the Rocket repository that we made at the very top of our app using context.read, which is basically just provider.of, right? It provides, or rather it fetches a Rocket repository from above in the widget tree. And that's how we make our home qubit. And what we do immediately after we've made it is we call fetch all rockets on it so that we start loading right away. So that when the UI is constructed, we've already kicked off the process to get those rockets, and then we show whatever we're doing, hopefully get the rockets in time. So we provide this BLoC so that the rest of our UI, in this case, the home view, can access that BLoC. And then we provide the home view, obviously. So that's our homepage rendering. Now, the home view itself is only concerned with providing the view for that rocket state. In this case, this home view is very simple, and it's broken up into multiple parts to make it easy to work with. This is basically just a scaffolding, right? So we have an actual scaffold. Then we have an app bar with a little bit of text. Now here we use that localization that we've defined before in order to show a home app bar title that comes from our English or Spanish localization. So in this case, I'm running on English. So that means that we get our English localization, although I do believe that the actual Spanish value that's in here is the same, so you wouldn't know. But if you put your phone in Spanish or any other language that you support, this makes sure that the right string is shown for that app bar. We do so using context.l10n, which is just an extension that we've defined in that l10n file that I showed you before. So we have a scaffold with an app bar with some text, and then the body is content, and we centered that. So let's have a look at the content then. So this is the bit that actually will do rendering depending on the state. Now, obviously, you don't need to structure your code in this way. We don't do it this way all the time either. It just very much depends on the feature that you're building and what state is in your qubit or block. But in this case, it's nice to split it up like this. So what we have here is the actual content. So first off, we need that localization bit again. And then we select the status. Now we do so using context.select. All this means is that, hey, fetch the nearest home qubit, which we defined at the top right here, right? Fetch that qubit and then only give me the status. So that's one part. It filters that qubit so that you only get the status from that state. But not just that, it will only make sure that this part of the UI is only rebuilt if that status changes. In this case, we only care about the status in order to determine what we want to render. If we had more fields, we could select multiple or just watch the entire state and rebuild whenever anything of the state changes. But in this case, we only care about that status. So that's why we select that status exclusively here. And that means that, say that our rockets list change, we don't need to necessarily rebuild this bit because the status has not changed. Right? So that's a way to more efficiently rebuild your UI. Now, depending on the status, we want to render a couple different things. So if we are in our initial status, we don't want to render anything at all because nothing's happening. So in this case, we just render the size box. We do give it a key. Reason being that this makes it way easier to accurately test it, which I'll get to in a second. Then, if we're loading them, we want to show some circular progress indicator, right? Center it, why not? In fact, I just realized that we already center whatever is in our content. So actually, this one isn't necessary, but still, we center a progress indicator to show that we are actually loading data. Then, if we have some sort of failure, then we want to show some text, again, using that localization from before. We show a piece of text that says, hey, something is going on. We can actually have a look here at what it says. In English, it says, something went wrong while fetching rockets. Please try again later. Perfectly fine. We can always change that in order to, we can always change that later, and nothing about our app has to change. So we show that text as an error message. If we do have success, which means that we successfully fetched our list of rockets, then we want to display that, have another widget for that, which is rocket list. So again, breaking it up into separate parts, the great thing about now is that if we render this rocket list, we're sure that we have some list of rockets, right, that we want to display. So this widget is only responsible for rendering that list. So what we do here is, again, we select a part of our qubit. Ooh, what's happening to my application? Is it updating or something? Ooh, it might be. It might be updating to an original iOS. Let me
nice timing for update.
Yeah, oh, I love it. Don't you love Apple? Let me open up an Android one instead because that one never complains. So let's go here, put it there. There we go. Perfectly fine. So while that boots up, let me go through. Let me go on. So in this case, that rocket list is only concerned about rendering a list of rockets. So what we can do is, again, fetch our qubit, our state that we've defined before. And then once we do, we only want to select those rockets that we have. Now, rockets is a nullable list because sometimes our list of rockets might be null, right? For example, when we have a failure state or we haven't loaded any data at all, it's going to be null. But since we know that this widget will only be built once we have that list of rockets, we can actually add an exclamation mark behind it to make sure that the compiler knows that, hey, this list of rocket cannot be null if we've reached this point. So that makes this a non-nullable list of rocket. And this rocket list UI will only rebuild if that part of the state has changed. So if our list of rockets has changed somehow. Now, let's have a look at what's actually rendering. It's not that super exciting. Basically, a list view, and then for each rocket in that list of rockets, we render a list tile. So this syntax is really nice, so I can go over this later if people have questions about it. But in general, for every rocket in that list of rockets, we show a list tile. Then, in this case, it's a 3-liner because we have a small description there, as you might have seen before. Then on top, we want to navigate to this rocket details page, which I can show you in a second. The title is going to be the rocket's name. It has a name field that just displays the name. Then as a subtitle, we want to show that description. Now, we do want to limit it to 2 lines because some of these descriptions are quite long. So we just want 2 lines. And when it does overflow, because that part is, that description is longer than those 2 lines, then we use an ellipsis to cut it off. Then as a trailing icon, we have just like a little arrow on the right-hand side that makes it easier to see that we can click on it. Now, for each of these list tiles, we render both the list tile and a divider here. That makes it so that it's nice and separated, that each of these rockets has a nice separation. So let's have a look. As it starts up, we load, and there are our rockets. So that's perfect. So in this case, we have 4 rockets that are fetched. And so we get that description, all that good stuff. Now, one nice thing to remember here, especially about the block and qubit structure, is that our UI has no state whatsoever, right? It's just a function of it gets some state, it produces some UI, and then when something happens, it performs some action. In this case, this UI doesn't even perform an action because there's not that much to do after the rockets have been fetched, but we totally could. So that's that part. So let's have a look at what this contains. So if I go to Falcon 9, for example, I happen to know that that one is currently in use. Then we get a nice description of the Falcon 9 rocket. So if we take a quick look at how that's rendered, it's basically the exact same pattern. The nice thing is you can use this pattern that we used for home and basically copy paste it and use it for rocket details. That goes for most features. You just add another folder, add some views, some qubits, an export file, and you're good to go. So in this case, our qubit is even more simple. It just contains the single rocket, right? You might as well say, why use a qubit for this at all? That makes sense, but in this case, we might want to expand this screen in the future, so it's nice to have a qubit to get started. Obviously, qubits, blocks, both of them are totally fine to use. Depends on whatever your needs are and what you prefer. Now, this rocket details page is very simple. It's very similar to how we had our other page. All it does is render a stack with a list view for this picture at the top. We have a title header that shows the title, whether it's currently active and when it first launched. Then we have a description section right here that just shows the description, most basic widget ever. And then if we have a Wikipedia URL, we can show that at the bottom here and click it to open it. Now, this is a very simple widget, and so the qubit itself is also very simple, but as I said, might expand in the future. It's nice to use a qubit anyway. The only special thing about this really is that it has a static method route that takes in one of those rockets, creates the block provider, and provides that qubit, and then renders the page. So that way, using this pattern, which we also use everywhere, we can, instead of having, rewriting this sort of material page route everywhere, we can just have one static method, and then when we need to route to this page, all it does is navigator of context, push the route, and give it the rocket. The rest is taken care of for you. So that's most of the application. And the nice thing is, for every screen that you want to add, every feature that you want to add, you could just take one of these folders, copy it over, add a little bit of logic, maybe change up the block, change up the name, that kind of thing. And this way you can quite easily expand your architecture. Same goes for the packages. Add another API, no problem. Add another repository, no issue, right? The structure is there and easy to follow. And so there's very little thinking work involved. That's the nice thing about it, because all the features look exactly the same. So whenever you need to add something or remove it or change it, zero thinking involved. Just add it and you're good to go. Obviously, you still do need to think about some aspects, but most of it is just almost like a copy-paste job because the template is well built and configured already for you. So that's the nice part. Last thing I'll have a look at is the tests, and after that we can have a Q&A, go into any more specifics if people want to. So our test is divvied up exactly in the way that we have with our actual features in the lib folder. So having a look at the app test, for example, we create a mock rocket repository that extends mock and implements that Rocket repository. Now this bit, the mocking part, comes from the Mockito package. Sorry, Mocktail actually, because we're doing null safety. We're using Mocktail, which is also built by Felix. Then we create a fake Rocket repository to feed into our app. And then whenever we render our app, we give it that fake repository. And then we can do all the testing we want. We can make sure that it shows that app view. We can make sure that in that app view, we render our homepage, right? Then in our homepage test, we can also, test the qubits, make sure that it does the right request. Whenever our repository throws some error, we want to make sure that the failure state is properly displayed, all that good stuff. And then same goes for the home view. It goes for everything, right? I think you get the picture. Now, nice thing about how this package is built, or this example app, is that we have 100% code coverage, as we've told you many times before. Now, this means that every line, every executable line in our entire application has been exercised or run at least once. Doesn't necessarily mean your app is bug-free. Doesn't necessarily mean that your tests are perfect. It doesn't even mean that what you've ran was actually the thing that was tested. What you could do is make it so that your entire application is run once and then test nothing at all. Make sure that a duck is walking on your sidewalk, whatever. It doesn't matter, but it gives, if you use it properly, a good indication of how much of your application you've tested. And it's also a nice reminder to have a metric that says like, hey, this bit of your app was never tested, and then you've probably forgot to write the test anyway. So if we do that, I have a little extra script for that, but it's all included in the GitHub workflows as well. We have one for the main application, which is very simple: installs dependencies, format, analyze, run tests, check the coverage. The exact same workflows go for the Rocket repository and the SpaceX API. Only these ones use Dart, don't need to use Flutter. I have a little script here that runs code coverage for me automatically. Running that will shuffle the tests. And then once this is done testing the entire thing, which should be pretty quick, just as a demonstration. What this will do is it will generate, and the script you can find online as well. It will generate this beautiful website, absolutely gorgeous, and tell us that our code coverage is 100% on this project. And then we can see exactly what lines were exercised, how many times, and when. So, and this will also tell you, obviously, if you're missing coverage. And this is all open source software as well, so that's great. So yeah, that's the example application in a nutshell, I'd say, or like a guided tour of it. If I haven't forgotten any parts of it, or Felix or Óscar, if you want to add anything to what I've been talking about, then please go ahead. But if people don't have anything more to add,
I think you went through everything. I didn't see any questions so far, but yeah, time
cool.
for the people.
That's a compliment, I guess.
Yeah, I mean, it was so well explained that like the few questions that I had throughout the presentation, you actually answered them as you were explaining the code. So I imagine
perfect.
It was kind of the same for most of our students. I do have a few remarks about what you just mentioned, like how well structured everything is. For me, like starting any project is super tedious, like setting up the entire environment, the folder structure, and how well this whole thing just puts, your entire project into one place. I love that part, so I'll definitely check it out myself. And also the part about testing, that is really impressive. The fact that you can get, a visualization of what you're doing right off the bat, really cool stuff. And I do have a question about blocks and qubits. I've used them in previous projects and stuff like that, but what's the actual use case for qubits versus blocks? Like, because I've used qubits, I've used blocks, and at the end of the day, like I can manage the state of my application and everything runs well. But it seems like sometimes qubits are easier to manage, while blocks sometimes are a little bit more convoluted and kind of like overkill. So what's this specific difference there?
Felix.
I was hoping you would answer.
No, man, you need to talk once in a while.
Yeah, no, it's a good question that gets asked a lot. I just dropped a link to the docs where we tried to cover that a bit, but basically I think the short story is if you don't need block, just start with qubit would be my recommendation, because as Jay mentioned, like it's a lot simpler. There's a lot less overhead, fewer concepts. you don't really have to think in terms of events and states. You just think like, oh, I'm calling a function and then I'm dealing with some result. So usually, especially if you're new to Flutter, it's a lot simpler, I think, to grasp. And I think blocks, you'll kind of, I think, get a sense when you need a block. If you start with Qubit and then you're like, oh, maybe I need to debounce something, like if I'm doing an autocomplete or search feature, or maybe I really want to know like what sequence of events led to a certain state and I want that in analytics or something like that. Like once you get to that point, then I think it'll be like obvious, and then you should hopefully be able to pretty easily refactor from Qubit to block. But yeah, a lot of that has been at least we tried to cover that in the docs. So hopefully that helps. But let me know if you need any clarification on any of what I just said. Hopefully that was a good overview.
Yeah, I mean, I guess it makes sense that you would use Qubits for something a little bit simpler in terms of state, and then when you want to actually, build up from there, you use a block. I think I've overkill a few of my applications just going for block right away, just in case.
Yeah, we honestly do that sometimes as well. Like we just use block for consistency. And like actually, I think a lot of times the way that we justify it is through logging and analytics. Like there's just information that you can't get by using Qubit that you do have access to by using block. So if you are comfortable with block and you already have experience with it, I'd say there's nothing wrong with just using it as your default. It's more for people who maybe don't feel comfortable with it, or they don't like the extra amount of code that they have to write. And if you feel like, oh, I don't get the value of this additional code, then that's what Qubit's there for. Like you don't need to go with that more like verbose and heavy approach. But if you are comfortable with it, it's definitely more powerful and flexible in my opinion. So I think there's nothing wrong with just sticking with it for consistency. I know a lot of people do that. Like one of our coworkers, Jorge, he's like, oh, I'd rather just use block everywhere. So I think everyone has their own opinion on that, and it's just what works best for you. I'd say just go for it.
Right. Makes sense. Well, thank you for clarifying that. It seems like we don't have that many questions right now. I'm sure that once we post this recording on our YouTube channel and, like people get a hand on this fantastic CLI, we may get a few questions and stuff, but we'll be publishing all these resources on our Telegram group. Maybe we'll reach out to you guys in case we find something interesting or we want to discuss something. But yeah, this has been absolutely amazing, especially because Flutter is just, going to the moon. Everyone is using it. It's super flexible, super useful. I personally love it. So thank you so much for your time presenting all this stuff.
Happy to help.
Yeah, thanks, Óscar and Jay.
Yeah, thank you.
Yeah, thanks for putting together that example app. We'll try. I'm not sure if we've done it already, but if not, we'll make sure to include the slides, like a copy of the slides as part of the repository as well. So people can also just go through the slides at their own pace.
Yeah,
awesome.
We'll get it in.
Yeah, maybe I'll shoot you guys an email just to gather up all these resources and then we'll put them together. But yeah, this has been fantastic, super useful. Hopefully we get a bunch of students involved in Flutter using BLoC, and they build amazing projects. Thank you so much, guys. It's been an absolute pleasure. And until next time.
Thank you. Well,
Bye.
Thank you.
Take care, everyone.
Bye-bye.